All right, section 6-5, conditions for special parallelograms. We are going to be looking at rectangles and rhombuses again, although this time we're going to be showing you ways to prove that it is a rectangle and to prove that it is a rhombus. So the first two will look familiar to you because we talked about rectangles in the last section. But this is how to prove that it's a rectangle. And so it is a rectangle if it is a parallelogram first, and if it has one right angle, then it's a rectangle. So you first have to prove that it's a parallelogram, which means you need to do one of those 6 different ones, either showing that the opposite lines are parallel, opposite lines are congruent, opposite angles are congruent, etc., etc. So you have to do that first, and then you also have to show that it has one right angle, and then it is a rectangle. So that would look like this. We have opposite lines parallel, and one of the angles is right. Then we know that it is a rectangle. It is also a rectangle. Instead, you can also prove that the diagonals are congruent to each other. So if we know that, first of all, it is a parallelogram by one of those 6 methods, and we know that the diagonals are equal, then we know that it is a rectangle. So that's 2 different ways to prove that a quadrilateral is a rectangle. So here are some conditions for rhombuses. Okay, so it is a rhombus if it is a first of parallelogram and one of the pairs of consecutive sides are congruent. So first of parallelogram, and also one of the pairs of consecutive, remember consecutive means next to each other, so this one and this one are consecutive sides. So if they are congruent to each other, then we know that it is a rhombus. Another way to prove that it's a rhombus is, first of all, if it's a parallelogram again, and this time if diagonals are perpendicular. So if you prove that diagonals are perpendicular, and it's a parallelogram, then you have a rhombus. And the last way is, first of all, a parallelogram again. And secondly, if the diagonal is bisecting opposite angles. So if this angle equals this angle equals this angle equals this angle, then we know that it is a rhombus. Okay? So let's kind of put all of this stuff together now. Don't worry about the top piece here. These are all of the ways to prove that something is a parallelogram first, and then to prove that it's a rectangle or a rhombus. And remember, it is a square if it is a rectangle and a rhombus. So if you want to prove something is a square, you have to take something from this box and something from this box and something from this box. If you want to prove that it's a rectangle, you have to take something from this box and something from this box. If you have to prove that it's a rhombus, you have to take something from this box and something from this box. Okay? So parallelogram, we've learned all of this before. Opposite sides are parallel, looks like this. Opposite sides are congruent, looks like this. Opposite angles are congruent, looks like this. One angle supplementary to 2 consecutive angles. So if this is x degrees, this would have to be 180 minus x degrees. And this would also have to be 180 minus x degrees. Diagonals bisect each other. And one pair of opposite sides congruent and parallel. So if this is congruent and parallel to the opposite side, then it is a parallelogram. So these are 6 different ways to prove that it's a parallelogram. If you want to prove that something is a rectangle, you have to choose one of these 6 ways first. Then you also need to choose one of these 2. And those are, again, if it's a parallelogram, which means one of these, and one right angle, or if it's parallelogram with diagonals congruent. Okay, and a rhombus, once again, you have to prove with one of these 6, so that's the parallelogram piece, consecutive sides congruent, diagonals perpendicular, or diagonals bisect opposite angles. And there you have it. And once again, if you want to do a square, you have to do one from here and one from here to show that it's a rectangle and a rhombus, and one from up here to show that it is a parallelogram. So these are the properties of our special quadrilaterals. Thanks for watching.